Hello everyone, this is National Weather Service Columbia Service Hydrologist Leonard Vaughan, and this is the 5th episode of Calculating the Odds, a video series on probabilistic weather forecasting. In this episode, we will cover National Weather Service products associated with hydrology. Just because the rain stops doesn't mean our job is finished. A variety of hydrological products are issued by the National Weather Service that addresses the different types of flooding we can see across our area. This episode will focus on probabilistic products we issue for flash flooding and river flooding. We will start by covering products for flash flooding. So what is flash flooding? A flash flood is a type of flooding caused by rapidly rising water levels, usually as a result of intense rainfall over a relatively small area, occurring within minutes to several hours on the onset of the event. Flash flooding is more likely when the rain falls over saturated or impervious land surfaces. Urban areas, such as along Rocky Branch Creek in downtown Columbia, are particularly prone to this type of flooding. There are many other urban areas around our CUWA, which is our county warning area, that are prone to this type of flooding, and those areas are included in parts of Lancaster County, Orangeburg County, Sumter County in South Carolina, and urban and suburban areas around the city of Augusta in Georgia. The National Weather Service will issue a flash flood watch when conditions are favorable for flash flooding over a given area. A flash flood warning is issued when flash flooding is either ongoing or is expected to occur shortly. When a warning is issued, National Weather Service meteorologists have the option to add a considerable or catastrophic tag to the product. If one of these tags is added to a warning, it will trigger the Wireless Emergency Alert System, or WEA for short. Base flash flood warnings will not trigger WEA. And a flash flood emergency is issued in rare situations when a severe threat and catastrophic damage from a flash flood is happening or will happen soon. The last time the National Weather Service office in Columbia issued a flash flood emergency was during Hurricane Florence in 2018. There are many tools available for our meteorologists to assess the potential for flash flooding. The first is called Flash Flood Guidance, which is an estimate of the amount of rainfall needed over a given area during a certain duration to cause localized flash flooding. In this example, the 6-hour flash flood guidance for the St. Andrews neighborhood of Columbia is lower than anywhere else in the state. The guidance information estimates that 2.5 to 3 inches of rain in a 6-hour period would produce flooding near this location. It is important to remember that it can take less rainfall for flash flooding to occur in urban areas and typically flood-prone areas. Once we have an idea of how much rain is needed to result in flash flooding, we need to determine how likely it is to occur. Using high-resolution model guidance, we can see what the forecast precipitation will be. In this example, the mean, or 50th percentile, for a 24-hour precipitation event for Columbia is only 3/4 of an inch, well below what is needed for flash flooding. Because the mean is well below flash flood guidance, it should come as no surprise that the probability of that area seeing greater than 2.5 inches of rainfall in a 24-hour period is low, and less than 20%. Another probabilistic product we can look at is the Precipitation Guidance, which is produced by the Weather Prediction Center, or WPC. The Weather Prediction Center creates probabilistic forecasts using their Quantitative Precipitation Forecast, or QPF, and an ensemble of model guidance to account for the uncertainty. These probabilistic forecasts are available in 6-hour periods and are summed together to obtain 24-hour forecasts. The example shown is the probability of a location seeing a 1/4 inch or more of rain during a 24-hour period for the continental United States. While much of the United States is expected to see dry weather, there is a strong signal over Florida, which was associated with the passage of Hurricane Milton. These probabilities factor into the WPC excessive rainfall outlook. The excessive rainfall outlook, otherwise known as ERO, is likely the flood product you are most familiar with. The ERO is a probabilistic product issued by the Weather Prediction Center for days 1 through 5 and highlights geographic areas where there is a probability of rainfall exceeding flash flood guidance within 25 miles of a point or location. There are 3 categories on the outlooks for day 4 and 5, and a 4th category for days 1 through 3. These categories are marginal, at least a 5% chance of occurrence, slight, at least a 15% chance of occurrence, moderate, at least a 40% chance of occurrence, and high, at least a 70% chance of occurrence for days 1 through 3 only. The examples shown is the Day 1 ERO for the southeastern United States on August 7th, 2024, as our area was dealing with the impacts from Tropical Storm Debby. Next up, we'll cover river flooding. While flash flooding occurs quickly and over smaller streams and rivers, river flooding is often a longer duration event. It can take longer for larger river systems to overflow their banks and for the water to eventually retreat. Since larger rivers are part of a larger interconnected basin, the rise is often gradual as water moves into the rivers from smaller streams. Across our CWA in the Midlands and Central Savannah River area, reservoirs can greatly impact how quickly or how slowly rivers will rise across the region. Like with flash flood products, a river flood watch may be issued when the potential for river flooding is possible, and a river flood warning is issued when flooding is ongoing or is expected to occur. Since rivers typically take a longer period of time to flood, we can reference products such as the river level probabilities table. These tables are used to estimate changes that a river will rise above a certain level during the forecast period. The example shown here is output from the GEFS and goes out 10 days. Each column shows the river level for a specified percent chance of exceedance, with flood levels on the right side of the table for reference. So for the Congaree River at Columbia, there is only a 1 in 10 chance of the river level exceeding 4.6 feet. Therefore, river flooding is unlikely at this location. By comparison, the Santee River at Jamestown is forecast to exceed their moderate flood stage of 17 feet, so the probabilities reflect this. We can look at this potential in another format by looking at the river level plume plot. This shows us the median forecast river level through the forecast period, in addition to the estimated range of possible river levels. In the example, you can see the Congaree River here at Columbia is unlikely to approach action level, which is 10 feet for this area at Columbia, but could see rises near the end of the forecast period. That will wrap things up for this episode of Calculating the Odds. If you have any questions, please leave them in the comments section, and we will go over them in the next video of the series. Expect our final topic to debut on our National Weather Service YouTube channel in the next month or 2. If you haven't already, make sure to follow NWS Columbia on YouTube and enable notifications so you are among the first to see our latest videos. We thank you for watching. I'm Leonard Vaughan, the National Weather Service Columbia's hydrologist, and I'm signing off until next time.